In this video, we're going to look at some more complicated examples of law of cosines by applying it to a word problem. And we're also going to explore how to find the area of a triangle using another set of new formulas. So here's the problem we're going to look at. They have given us a lot of the information for what a baseball diamond looks like. And they've described that the bases are 90 feet apart. So that's what's describing this length here. It's also describing the other lengths from first base to second base and second to third, but we're not really interested in those right now, so none of that is filled in. They've also talked about the front edge of the pitcher's rubber, so that's where this capital B is located. This is the pitcher's rubber here, and they're saying that the distance from the front edge of that to the back corner of home plate, which is down here, is a length of 60.5. They've also filled in that length of the triangle for us as well. And then what they're asking us for is for us to find the distance from the center of the front edge of the pitcher's rubber right here all the way to the far corner of first base. So it's this length that has been labeled with a lowercase c. Now the original problem did not tell us that we have a 45-degree angle in here, but the diagram has given us that information. I do want to point out though that we should not just be assuming that this is a 45, 45, 90. In fact, it's not, because the pitcher's rubber is not exactly halfway between the first and third base. So that's why we're going to have to use our newer techniques, law of sines and law of cosines, to solve for this one. Now, the reason we can't use law of sines on this particular problem is because even though I have two sides of the triangle and an angle, we don't have any of the angle and side pairs. For example, I don't know the side opposite this angle, I don't know the angle opposite this side, and for this side, I don't know the angle opposite it. So in this case, we wouldn't be able to use law of sines, but whenever given the choice, that's usually the technique I prefer. On this problem, we're going to have to set up the law of cosines instead. So plugging the numbers from the diagram into the law of cosines gives us 60.5 squared plus 90 squared minus 2 times 60.5 times 90 times cosine of 45 degrees. So now we just need to take all this information and type it into our calculator. And remember that that's actually equal to c squared, so we'll also want to take the square root of both sides of the equation after doing that. So computing these numbers gave me a value of 4,059.857153. And the decimal went on a little bit longer, I just stopped there. And then when I took the square root of both sides, this gave me 63.717008. Now this question does not have specified in the directions what they would want us to round to. A good rule of thumb, if they haven't specified, is going to 3 decimal places. That's kind of a good starting point. And then you can always just come back or ask if there's a more specific rounding instruction that should have been given and was left off. So that's it on this one. They didn't ask us to solve the entire triangle. We did not need to find the other angles, even though we could have. They only wanted that one side. And that's one of the things that the law of cosines is good for. It's really good for pinpointing one particular value that you need, instead of solving for the entire triangle. So here we have another concept very closely tied to the law of sines and the law of cosines. Sometimes we will not be looking for the side lengths or the angle measurements of the triangle, but instead we'll be looking for the area of the triangle. And so we have 3 different formulas that can be used here. These are a little bit more complicated than the common ones used in geometry, where you have area of a triangle is 1/2 base times height. Those only work for right triangles, so now we have formulas to work on different angles inside of the triangle. So pick whichever one is easiest to work with based on which sides and angles you have in the problem, but then this is a pretty straightforward process of just plugging the numbers into your calculator and then rounding to whatever the question asks you to. So here's a short example where we've been given an angle of 52 degrees and then 2 of the sides, and they have asked us to find the area of this triangle. Then we will be rounding our answer to the nearest square meter. Now it is possible that you will be asked to find the area of a triangle and you might not have all of the information you need, in which case it's good to know the rules for law of sines and law of cosines to find any missing sides or angles. But then generally, once you get those measurements determined, you can just figure out which formula best matches the numbers you know. So we have angle A, side B, and side C. So here's a formula that uses angle A, side B, and side C. So I'm going to be using this top formula, and I'm just going to do 1/2 times both of the sides, and then multiply it by sine of that angle. So here's what that should look like after performing your substitutions, and then you're just going to go ahead and multiply the numbers through. Always feel free to take shortcuts, like since we know half of 14 is 7, you can just break it down as 7 times 21 times sine of 52. All of the numbers are being multiplied, so you can always try and use the 1/2 to simplify one number or the other and reduce how much you have to type into the calculator. So after computing this in the calculator, I got a value of 115.8375808. And then again, since the directions asked us to round to the nearest square meter, no decimal places on that, we rounded this to the number 116. So that's it for this lesson. If you found this video helpful, then please hit like, subscribe, and/or comment.